Okay, we're going live now for an ad hoc video presentation of the current structural modeling software interface. Wanted to basically show these architectural decisions that were implemented based on the requirements that were collected from Kevin Dye and some other people over the last couple of weeks. We essentially, what I have up now is the structural modeling project interface. What I've done is I've taken the suggested commands and software allocation from the George Mason University Interpretive Structural Modeling software commands that were in the Interactive Management Handbook and implemented them in a couple of specific ways. Well, we've covered the do priority command and the do cluster command out of the Interactive Management Handbook. So we can see here we have the cluster objects into classes, that's the do cluster. And the do priority, basically what I've done is I've broken those into two specific applications. One that only allows one object per class, and the other one is an ordering that allows one or more objects per class, which are still ordering the classes. Let's just take a look a little bit at this interface. I have the structural modeling project here, which basically redirects to the system's concepts website. Some things to notice there. One is I've upgraded the website to HTTPS. We'll be adding some more features to that website as we go along. And also, besides having the structural modeling reports, one thing that's on our website is our standard matrix examples. Now, these standard matrix examples work with the evolutionary programming approach, which I haven't been working on in about the last year or so, but we'll probably start working on after we get the logical-based system working. Of course, then this home button just brings us back to the home interface here. The about button, basically this describes a little bit about the current project and what we're doing. And the details page then takes us over here to the document page, which gives an overview of the application and also talks about the do priority, the do cluster, and the do model. Now, I haven't done the do model yet. That's one thing we're going to be implementing, but we haven't started doing that yet. And then we have more placeholder documents here where we're going to put specific examples of each one of these software functions and software little web applications, how you use them, so forth. So that will be also part of this. Obviously, they're not filled out yet, but that will happen in the future. So we have these parts of the application. Then the documents is the one you've just seen. Basically goes through and talks about the components, what they are, and then gives the pointers to the more information. An overview document, which we will develop later and give specific steps for people to follow to introduce how the software works. License, basically this is GPL version 3 license, and these it's under an open source license, and this will continue to be that way. If people need different types of licenses, be sure and let us know. We'll be able to figure out how to handle that. And then the contact page We have, again, back to the website, and then additional information also on ResearchGate, which basically lists many of the documents and presentations that explain what's going on with this structural modeling approach and what needs to be done. So that's kind of the general bar, there's the selection bar, menu bar at the top, and what's happening there. Then we have the 3 approaches that we've implemented so far, the strict order with 1 object per class. This is like a priority matrix or prioritization where you force people to make a distinction between each item. You don't allow any 2 items to have the same priority. So be distinct at a distinct level and a distinct priority. No 2 items can be at the same level. So there's a strict order of this with only 1 object per class, and we're ordering the classes. And this next one, we have a strict order, but we allow 2 or more objects to be at the same priority or the same level, depending upon what the natural language relationship is that you're using to structure the system. And then, of course, the bottom 1 cluster object in the classes. This is a do cluster, and basically what happens here is you identify things that are the same kind and cluster them into groups. We can see here the get more information. We'll go back and actually connects to the same pages that are not filled out yet. But what these will have specific small examples, step by step, of how to go through and use the software. So let's just say now we're going to do a strict order, 1 object per class, and this matrix is size 9. And so now what happens here is we go to the next page over, which shows us our grid, how we can start entering our data. So we say 2, north of 4, do that data, and that's correct. Then we'll say that like 6 is north of 1, and we'll enter that data, but we'll also have to swap that. Now, in these specific approach that we have here, the human operator has to make the decision on swapping entries and inferring information. One of the requests for an improvements in this was to actually automate that so that the software would detect when things needed to be swap automatically, and also to automatically, once you hit the enter data button, do the inference if it's required. So those will be 2 types of software improvements that we'll be adding, but we'll be adding those later on as we develop this process. Okay, let's go back here to the main page, and we'll look again and we'll say, okay, now display 1 or more objects per class. So we'll put a 9 here, 1 or more objects. Now we can see one of the primary differences between the single object and this one, the 1 or more objects. We ask, are the entries equal? So we have an equality statement here. And so we could say, okay, yes, we know that 2 and 6 are equal. Okay, we'll enter that data. We can see here now that the matrix has gotten smaller, and 2 and 6 down here are equal. And we can say, well, are the entities equal? And we can say, no, this time they're not equal. We're going to say 3 is north of, let's say, 7. All right, enter data. Okay, so we can see we have that, and then we can have 8 and 4 into that part. But again, this is a manual process right now of swapping these, so we'll swap those down below. That can be automated, and the inference of the data can also be automated. That's this type of operation that we'll be using there. Then the next one is the cluster objects into classes. I'll show this particular one. Now in this case, there's no swapping and there's no inference because all we're doing really is just clustering things into classes. And they'll actually be, so let's just take a look. So we'll say now that like 3 and 6 are in the same class. So we have a 3 and a 6. And then we'll say, okay, 1 and 9 are in the same class. Okay. Then we'll say 3 and 5 are in the same class. Do that data. So we can see here that we're taking grouping these classes. Matrix is getting smaller, but we have no green ones because there's no entries into the matrix that's related to the relationship. They're saying the same as we're pulling them out and letting 3 represent 5 and 6 here, letting 1 represent 1 and 9, and then we're clustering these into groups. So this is basically where we've gotten with this, and we will be improving it as we go along. And we'll entertain any comments, requests for improvements, and I will try to get further development work done on this and post another video maybe in a week or so. I'd also like to find some people that I can test this new video interface with YouTube with before our next meeting in November, and get it kind of ironed out. But with that, I'm just going to basically say essentially what we've done is we've implemented these 3 functions, software functions that are from the interactive management book. It's a strict order with 1 object per class, a strict order of 1 or more objects per class, but we're strictly ordering the class, each of the classes. We're not really strictly ordering the objects. We're actually ordering the class, these classes, because we have here we have for each object actually is its own class. So in that case, you could think of it as being a one-to-one relationship, but in this case, when you have more than 1 object per class, then it's really not a one-to-one as well, or strictly ordering these classes. And then, of course, we're creating the clusters. The do model, which takes into consideration a more general type of algorithm, we have yet to implement that. We'll be working on that as we go forward. And we look forward to identification of people that would like to help us with tests, creating a test bed, and also people that are interested in using this, and providing requirements and suggestions for improvement. So take care and have fun.